On previous sessions, we discussed regarding up counter and down counter, right? Now, today's session, we are going to discuss both up counter and down counter in a single module. Now, we will see how to write a code for it. Okay. Just use a module keyword and we have to give a name of our module. Here, I am just giving as a up down counter. Now, I am declaring a input and output ports. Reset, clock. Here I am taking a two pins, just like up and down. Now, when it comes to the output pins, output rich, here we are using a 4-bit down counter. So I am just declaring as a uh, output rich 3 down to 0, 4-bit out. Okay. Now, always at the rate passage clock begin. If reset equals to 1 means our circuit has to be in off state. Okay, so I am making my output equals to 0. Why I am here declaring as a 4 tick b, because our output pin size is 4-bit, right? So I am declaring 4 tick. We are representing that value in a binary format, so we declare tick b. Okay, else else is nothing but if reset equals to 0. At the same time, if it is a up, if up is triggered means our output should be out plus 1. Else if it is a down means our output equals to output minus 1. Here we started with begin, right? So we just closed that one first and module. Now our design is completed. Now we will just save our file. I am just saving it. UD counter. Okay, nothing but up down counter dot v. Now we will see whether our code is compatible or not. Is there any issues or not? Okay. For that we have to use vlog command and file name. Here you can see the file name ud underscore counter.v. If you see here our code is successfully compiled with 0 errors. So we need to write a test bench for it now. Okay. For that I am just creating one more module. I mean one more file, module tb. When it comes to test bench, what are the inputs that are becomes as a rich data type? Rich, clock, reset, up and down, right? When it comes to output pins, we declared in a TB as a wire data type. Okay. What is the output size in our design? 3 down to 0 out. So I'm just declaring that. Now what we have to do here is whatever the design module name, just copy that design module name and just go to here and paste it over here and just give one name. Here I am just giving name as A. Yes, okay. Now here I am just making instantiation, just clock equals to clock. Nothing but I am just giving a connection between this this test bench and design. Okay. Up equals to up and down equals to down and out goes to out. Now we have to generate a clock. For generating a clock, initial begin. Initially our clock is 0. Forever #5 clock clock equals to negation of clock begin at initial begin. Now we have to pass the inputs. First we will check reset equals to 1. At that time our circuit not has it's nothing but our circuit is in offset. After 10 seconds we are making that our reset equals to 0 according to our design. Now our circuit becomes active now we have to pass which has to be performed. For example, now I want to perform up counter. So I am just making my up counter equals to 1. At the same time, I am making my down counter equals to 0. Why? Because at a time we can perform only one operation, right? So either we can perform up or either we can perform down. We can't perform both at same time. So after 100 seconds of delay, I am just making my down counter. See, sorry, my down count, my up counter, I'm making the off, and I am activating my down counter. Okay, and this is our test bench. Our test bench is also completed. Now I am just saving. Now we will compile this file also. Same command for that. Vlog. If you observe here, our test bench file name is ud_tb.v, right? ud_tb.v. If you observe here, our test bench is also successfully compiled. Now we will simulate our test bench. Okay. For that, we have to use vsim command and module name of our test bench. Here our module name is tb, right? So I am just putting here tb, and I just pressed an enter. Now it will open like this. Just right click on it, add to wave all items in region. Now what are the input and output ports will added in the waveform? Here you can see clock, reset, up, down, and out, right? Now just run this one. If you observe this one, okay, here you can observe. I will just make this as in decimal representation, then you will get some more clear idea. Okay, radix decimal. Here you can see when the reset is becoming low, from the next passage, our output is becoming increased. Why? Because at that time our up counter is high and down counter is low. According to our design, our up counter has to be performed. So start initially it is 0, 1, 2, 3. It's increasing continuously. Okay. When our just give me 1 minute. I will change in binary. That is more clear. See, 001 is nothing but 1. This is 2, 3, 4, 5, 6. It's continuous. It is 7, 8, 9, right? This one is 10. When it comes to here, on the next passage clock, the output will vary here only, right? At that time, our down counter, our up counter becomes low and down counter is becoming high. That means now we are performing down counter operation. Here up to our count value is 10, right? Now here, if you observe here, it's becoming 9 on the next passage. On the next passage, it's becoming 8. On the next passage, it's becoming 7, and continuously it was decreasing. This is how we used to analyze the waveform. Okay.